Well, good day everyone and welcome to the shop. It's been quite a long time. A lot's changed. That is a subject for a video at a later date. Today I've got a little project that I need to do and I'm going to do it on a new to me Clausing Colchester. This is a 67-68 model Clausing. It's the 1340. This is about 30 something inches on center. I just got it rough set up. I've been dying to use it. I'm the second owner of this machine. It came out of a machine shop. A gentleman bought it brand new in 1968, 69, and he's used it ever since. Spent a lot of time cutting plastics. So I'm pretty excited about this machine. It's one of my bucket list lathes. But before we get into all of that and what's been going on with the shop, let's take a trip over to the bench and I'll show you what we're working on today. So what we're going to be working on today is we have this hydraulic cylinder. It comes from my neighbor. They have a dairy farm over there. I don't really know what it does, other than it presses against the valve or something. Anyway, it's broke. It's got a few interesting little features on there. It's supposed to be threaded, and they were able to get the part that broke off out, but they lost it. So it's still not too difficult to extrapolate the dimensions that we need. Even if we didn't have it, I could have gone down and looked at whatever this interacts with and figured all this out. So I didn't do anything up on CAD or anything. I gotta get this back to them. So I just made just a real down and dirty rough sketch with some critical dimensions: the angle of this chamfer, diameter of this button, shoulder dimension, thread dimension. It is a 20 threads per inch. And so let's head over to the new to me Colchester and get this part knocked out and see how the new lathe works. Okay, so before we get going, a quick introduction on the lathe. This is the new to me Clausing Colchester. Just barely got it. I think I got a real good price on it. Came with everything: steady rest, follow rest, the original turret tool post with the certificate of authenticity, the owner's manual, the original certificate of authenticity or accuracy for the lathe, and the whole 9 yards. So a little bit about this lathe. This is somewhere around a 67-68 model. I'm the second owner. The gentleman I bought it from had a precision plastics machine shop up in Richland on the I think it's northeast side of Dallas, just outside of Dallas. Anyway, he's retiring. This spent most of its life turning plastic. It's the original paint was a gray, you know, the traditional tool room gray on the bottom with the dark blue top. You can still see that green zinc primer from the factory. What's really cool about this lathe is the tolerances that Colchester put into these back then. You know, we hear a lot of talk about accuracy and precision and things like that, but then when you get into spindle bearing run out and things like that, you're somewhere down into the 10,000ths. Back in the 60s, Colchester used gamut tapered roller bearing. They made their own bearings and they were sized accordingly. So every bearing was matched to its race by size, And basically, this machine, the certificate of accuracy on this machine, it was guaranteed to a spindle bearing run out of 3 microns. That's 3/millionths of an inch. So perspective, you have tenths, hundredths, thousandths, 10,000ths, 100,000ths, and then you're into microns. 3 microns, or excuse me, 3 microns. The certificate of accuracy states that this can turn apart back when it was brand new to within 30 microns of accuracy, so less than half of 100,000ths. Pretty cool that they had all that technology back then. I'll do a whole video on this deal later, and I'll link in that video some old Clausing Colchester videos. Video about their process for making these things. It's pretty neat to watch. Anyway, it's kind of an interesting machine to run. Cuts threads. It's got a heavy feed rod. Again, I'm not going to get into all that too much. It did come with a Pratt and Bernard, or Bernard, however you say it, 6-jaw. They call it a grip set or a grip true chuck. It's a true set, so you can dial this in to within less than a 10,000th. I'm not really going to mess with that today. I don't need to. You know, if it's within 3,000ths, you know, we're going to turn the stock down. It'll be concentric when we're done. So anyway, this is the first real operation on this machine. So let's get to making this part. Okay, so I think we're about ready to get rolling on the old Clausing. I've got you set up on the back of the machine. The camera is attached to the chip guard. The chip guard is, they didn't make them as, you know, it's there. It's rugged, but there, you know, most modern machines, it attaches somewhere to the rear of the bed, as well as the headstock. This does not attach to the bed, so that end is a little bit loose. You know, hopefully it's not going to move around very much. It seems to be a pretty smooth running machine. This is a 3-phase machine. It's a 3 horsepower, 2-speed motor. We're going to start off and see how it does at 570 RPM with a feed rate of about 4 thousandths per inch. This is some pretty gnarly material until I get back in here. Our first cut's going to be 30 thousandths deep, so we'll be reducing the diameter by 60. It's a pretty big cut. Let's see how she takes it. It does look like I have 2 dimensions on this piece of steel, so we're going to get it trued up, and hopefully we don't come out undersized. We do need to be right around that 875 mark for the button, overall button diameter. Making a pretty good chip. Not a bad little machine, nice and quiet. Let's go ahead and get a rough measurement. Let's see where we're at. So we're at 945. So we're at 945. We need to get to 875. So we've got 70 thousandths. We need to divide that, cut that in half. So we need to reduce the diameter of our part 35 thousandths. So 10, 20, 30, 5. A little bit of cutting fluid. Now, what better way to check the accuracy of the machine? We're just going to turn her loose and see what she does. When I originally set it up, it seemed like it should be pretty true. There was nothing really wonky about the setup in this machine, a little bit more fluid. Leaves a really spectacular finish. These are used, I didn't change the cutters out. This was the tool post and the cutters that I used in the jet lathe. So it's not like we're even working with new cutters, new inserts. Let's go ahead and get a dimension check. We are 875 and 5/10 thousandths. I'm going to call that good enough. Like I said, this is just a button. So then if we register our drawing, if we go off our drawing, our next dimension is going to be the shoulder, and I'm going to turn the whole thing down in steps, which is a depth of 900, or rather a length of 980 thousandths. You know, I need to face this off real quick. Normally I keep all my materials faced off and chamfered and ready to go. This came out of the scrap bin. So it wasn't ready. Kind of not used to that. Looks like it's cutting right on center. Got a little bit of an interrupted cut. You can hear it. Probably you can see it. I think we're gonna get after it pretty good here now. Yeah, it's set up real good. So that's 10, 20, 30 thousandths. See if we can get this done. There we go. A little bit of cutting fluid. I use the Tool Cool 2. fluid. You just want to make sure you clean everything up after you use it. You don't want it sitting around very long. It does get gummy pretty quick. That looks good. We'll go ahead and scribe in our 980 thousandths mark. And then we'll go ahead and scribe in our finished dimension, which is 1.3052 as well. So our next diameter is 580 thousandths. That's that shoulder. So we'll go ahead and we'll come in and we'll touch off, set my 0. I'm going to go 50 thou. It's 100 thousandths depth of cut, 100 thousandths off the diameter. Whoop. Let's try that again. We got to get used to the functions. We got our 0, 50 thousandths. So 100 thousandths off the diameter. Let it rip. We'll get a measurement after this cut. Right there. It does a real nice finish. We're at 770, 77. Let me check that again. 772 and a half. We need 580. So we got about 96 and a half thousandths that we need to go. So I'm going to set my 0. It'll be about 2 passes. $50 thousandths. Check our measurement. We're at 662. Well, 661 and a half. So we got 40 and a half thousandths. So really very accurate little machine. So we're going to go ahead and we're going to take 40 and a half. 40 and a half thousandths. little bit up by hand. We'll face that up. At the end. So let's see where we're at. 581. We need 580. That's really pretty good. Let's go ahead and crank the speed up, and we'll take that thou. Alright, let's see where we're at. I do like having the brake up here on the headstock. Excuse me. So we are at 580, right on the money. 580, 580 and 5/10. It's plenty good. Our next dimension is that 460. And that needs to be a depth of 700. So we are going to kick this back down into low gear. We'll mark that shoulder at 700. Right there. Gotta remember it's that first scribe mark. I'm going to reset my 0 on cross slide. I'm going to take 25 thousandths. So it's 50 thousandths off the diameter. Right there. Let's see what our reference measurement is. So we're at 520, 527, right on the money. Not that that matters, but for 527 we need to get to 460. So we got about 33.5 thousandths to take. So I'll set my 0. $31, 2, 3.5. Just facing that edge real quick. $460. 460, right on the money. This machine is, wow, 460, 459 and 5/10. Again, that's really, really good. So I haven't really done much as far as setting it up. I'm going to go ahead and chamfer this edge. There. Now we're going to get set up. Let's get this backed up a little bit. I have a little bit more adjustment. They had it wound pretty far forward. There we go. So I'm going to go ahead and get my zeros. I just bump. I thread kind of fast, I guess. I don't know, but I'm just going to go ahead and get everything zeroed. Back it out, come over here, go back to my zero. This is a 20 threads per inch. So we'll go ahead and set the machine up for 20 threads per inch, which is DA. We're going to slow it down to 236 RPM. That should be good. Engage our feed. I'll do a video on threading and how I thread someday. But right now I'm just going to take about a 2/1000 depth of cut and make sure that our threads are 20 threads per inch. That looks good. You're probably like, how do you know? I don't even know where my thread gauge is. Here it is. You do enough and you kind of, yep, 20. It doesn't hurt to check, make sure that the gears are right in the machine. It looked like 20 threads. If it was a metric thread at that pace, it'd be really goofy. So we're going to go ahead and now we're going to let her rip. Threading up to that shoulder it can be a little intimidating when you're first starting. I just really pay attention to my dials. I have to get my glasses and we can see what we got. It looks like they should be pretty good. And what I'll do is I'll check them on the actual part. That's why I haven't backed out yet. Well, that looks really good. Let's check it with our cylinder. Yep, it's a good fit. So next we will go ahead and see if we can't get these faced off a little bit. So we're going to disengage the feed. We're going to take our speed back up to the 570. And I'm just going to give that just a little bit of an undercut, just so I know it really can get on that shoulder. Same thing here. There. Now, thought I had a file over here ready to go, but apparently I don't. There it is. We're going to go ahead and get these edges broke. I'm going to want quite a bit more RPM. We're going to go up in the high, which is 1140. And now we'll go ahead and gear it down. See how we do at parting. That should be 153. Yep. Get our parting tool. I'm going to use just the regular rapid tap and just pretty much I'm going to do this by hand. Let's get the saddle locked down. Sorry if I'm in your way. So I'm going just a little bit heavy. I figure we can, gotta be careful when you hear that noise, it's galling. Need a little bit more fluid. Parting requires, seems to me, a lot of fluid if you want to not dink around with parting and take all day. Okay guys, sorry about that. I ran out of camera time. But anyway, so we got it cut off, I got it faced, and now we've got to cut that 50-degree chamfer. And so we'll go ahead. And the only thing I see with this is that mark is really, really faint. But you can see it. It's just, I'll probably pop that off there and very carefully get it set up in the mill and scribe a new indicator mark, or you can just had that probably a little tighter than I needed. or you could probably just use a protractor. So that looks pretty good right there. So we've got our compound set to 50 degrees. I'll be turning on the back side so it can, or I'll be turning on the front side so the compound's angled this way. The compound handle is on the back, so I'll be pulling it into from wide to narrow. And we need to set our speed. We'll go back to 570, which we should be right there. There we go. Get our file and break those edges. I'm going to go ahead and crank it up. All right. Let's go ahead and head back over to the bench and see how it looks. Okay, so we're back at the bench. This is the part that was broke off. This is our replacement part. I didn't blow it off or anything, so it's still got some chips on it. But let's see how it looks. Good thread fit. Bottoms out nicely on that shoulder. I think we got a winner chicken dinner, so they can get back in business. Well guys, we got our part finished. Came out really nice. Very happy with this old Colchester. Like I said, this is really a bucket list lathe for me. In the world of gearheads, these were a very quiet machine. Probably more so than their variable speed counterparts, and they were back in the day really the epitome of precision. Their counterparts were the Hardinge HVLH lathe, which were outstanding machines. They're almost identical. So again, this is Clausing Colchester. I think I misspoke and said it was a 1340. I believe it's a 1336, or at least it's 36 inches on center with this chuck in here. It may be 40 inches on center if you actually use a center. We'll find that out. But just very pleased with its operation. Turned those parts out beautifully with a really above average finish for that kind of part, way beyond what I expected. And again, you know, it's like using an old friend. So you'll see a lot of this in upcoming videos. We're going to go through it, and I think I'm going to go through a whole, we're going to go through setting up a lathe for gunsmithing. And I think this is going to be one of the lathes that we use to really step this up, to bring it into a little bit more modern age. The accuracy and usability is there. The other thing I'll mention, because I'm sure a lot of people are wondering about the through hole, this is an 1 9/16 spindle through hole on this. The only weird thing that you have to work around, and that's why I want to do a video on this, is it is the L0 spindle, so it's an odd setup here, but I'll show you some ways to get around that and make this really a high-end gunsmithing lathe, especially if you're really looking for tight tolerances. Really a pleasure, again, just really a pleasure to use, and man, without, you know, just basically throwing it into the fire and saying, let's see how you do. That's pretty good. That's not a high precision part, but we did have to cut some angles. We had to, you know, our thread dimensions had to be pretty exact. I wanted our dimensions to be exact so we could judge this a little bit. I don't think in that application, really the only critical dimension on there is the thread. Outside of that, you probably could have got away with a lot of different things, but it really did a good job. I'm really glad to have found this guy. So anyway, guys, we'll catch you next time. Videos coming up, obviously. I'll show you all the new shop. I've got a bunch of new equipment. Just a little teaser, sold the jet lathe. This is actually the replacement for the jet. But I've got what I call Big Blue. Really, that thing can move some metal, so its real name is the Big Blue Pig, because it just eats metal. It's a 1680 10 horsepower machine. So we've got that to go over. We've got the Colchester and the new mill. I got rid of the Wells Index. This guy got a really good deal on that, and sold the Precision Matthews and really upgraded to an Alliant 10x52 knee mill. It's a big heavy machine. I've already used, you'll see that in upcoming videos. It's got everything you could want. It's almost a CNC, really. But that thing is, again, it's just a pleasure to use. So all of that stuff will be in an upcoming video. Hopefully you found some satisfaction in watching this old lathe make some new parts and get put into service again. And we'll catch you next time. Thanks, everyone.